So welcome to the fourth online session of the Electricity Storage Network annual conference. My name is Ollie Frankland and I'm the Electricity Storage Network lead, and I am going to be chairing this session. So for those that haven't engaged so far, I hope many of you have, but this is a part of a whole series of online sessions that have happened over the last couple of days. And we also had the in-person conference at the IET on Embankment in London, and a couple of our panel members were there, so they were aware of what went down. But it's just to introduce that very quickly. It was a really good opportunity to kind of bring together the industry, see some members face to face, and yeah, I think it's fair to say we're really good buzz in the room. Lots of excellent topics. And a brilliant collection of people. So thank you for those that made the time to attend. I'll just introduce the Electricity Storage Network as well, very briefly. So we are the voice for the Electricity Storage Network for the electricity storage sector, in the UK. We have over 60 member organisations now, covering everything from developers to optimizers to asset owners. And we have 5 very active working groups, which have kind of informed the agenda for today, including one on fire safety. And so that's been the kind of the purpose, is to try and show some of the work we've been doing and kind of have a really good discussion around it. And so today is going to be a panel session. So I'll be introducing my panel in just a second. But in terms of how it's going to work in housekeeping, you have the opportunity to use the Q&A function. So for questions, please do use the Q&A function. And for general discussion points, use the chat. And a quick reminder that within the Q&A function, you can like or uprate questions. And that'll be really helpful from my perspective as chair to kind of see which are the most popular questions to ask our fantastic panel. And yeah, the chat function, please just use it as a discussion board. So if you've got anything that you're working on that you think is particularly interesting, that relates to fire safety, any links, introduce yourself. That's the use of the chat function. So please do use that. We will be recording the sessions, so they all will be available free online, and that will be going on to the event webpage. So you should have a link in your emails, or you can just Google the Electricity Storage Network Annual Conference 2023, and it will come up. So I think that's it from a housekeeping point of view. If we just move on. So just to take a minute or two just to introduce some of the work we've been doing at the Electricity Storage Network around fire safety, and primarily it's been focused in the working group, the Sustainability, Safety and Supply Chain Working Group. And for the last year or so, we've looked at fire safety as a kind of particular focus area, mainly because there's just been lots of feedback from members and from the industry that there's a lot of pressure on that aspect, that topic at the moment. So we've tried to kind of, yeah, I think that the way we've been approaching it is to kind of try and share best practice. So identify what is currently happening in the UK market, try and look abroad into the international scene, and pull in kind of examples that perhaps other territories are doing something slightly better around fire safety, and particularly around. So this is when we're talking about fire safety, this is kind of grid scale electricity storage here, particularly focused around lithium ion, I think it's fair to say, and yeah, we've been having a regular catch-ups, so quarterly meetings for the last few years on fire safety, and some very good discussions around what should be doing, and some pulling together some of the key organizations that are doing really, really good things. And that's the point of this discussion, really, is to showcase some of those excellent organizations and really open up that discussion a bit further. Great. So without further ado, I'll try and move on and introduce our panel. So yeah, I'm a kind of substitute. So apologies if you're hoping to see Sophie. Sophie's ill. I'm substituting in as chair today. So you've probably got bored of my voice already, as I've done 2 other sessions yesterday and I got another one later, but hopefully I'll be a good substitute for her. So I'll just quickly introduce their slides and then they can introduce themselves in a second. So Julian from Fluence, so obviously OEM, doing a lot on fire safety, a really good international view of the market. Dr. Kai-Philipp Kairies, based in Germany, but doing a lot of work across Europe, particularly, and in the UK market as well. ACCURE. Matt Aldridge, the head of electricity storage at BEIS, the Department for Business, Energy, Industrial Strategy, effectively kind of trying to direct the policy around health and safety and electricity storage more generally. And finally, Taylor from EPRI, Electric Power Research Institute, who are based in the US and have been doing some really excellent work about collating best practice on fire safety and some really interesting research findings. Right, okay. So I think I will ask my panel to introduce themselves, and there's a couple of slides just to help with the introduction as well. So I will go to Dr. Kai-Philipp Kairies first to just introduce ACCURE and some of the work you guys have been up to. So over to you, Kai.
Awesome, thank you. So yeah, my name's Kai. I'm the CEO and co-founder of ACCURE Battery Intelligence. I'm an engineer by education, spent the last 14 years in the battery world and had the privilege to lead the largest research group on stationary batteries in Europe for a few years before spinning out to join and found ACCURE. So what we do at ACCURE is basically we're making data that batteries already generate more usable. And we support companies that build, own, or operate battery assets in leveraging that data to make them more safe, more reliable, and more sustainable. So, you know, this is a panel on battery safety, and it's on everyone's mind. We have seen the incidents, you know, Moss Landing just a few months back, but many others before that. And we have found that using data that companies already have, we can substantially reduce the risk of thermal runaway by early prediction, by just shutting a system down weeks before something really happens. And the nice thing is it scales really well. So this is not, you know, a hypothetical research project, but we're at the moment managing about 2 gigawatt hours of storage assets, and we're onboarding another gigawatt hour over the next 5 months. So we'll be at 3 gigawatt hours pretty soon. A big percentage of that is large scale BESS in Europe, especially in the US right now. Huge market opportunity. Maybe if we can, I think there's one more slide. Let's see what, oh yeah, that's just marketing. So we've been doing that for quite some time. I think there's quite a few interesting examples. I'm very happy to share them, how it looks in the reality. Looking forward for the discussion.
Thanks, Kai. Much appreciated. 2 gigawatt hours is quite considerable. Yeah, that's a fair amount of capacity you've got in your portfolio there. Taylor, I'll go to you next, and you just got one slide just to introduce your company and what you guys are up to.
Yes, thanks, Ollie. Hi everyone, I'm Taylor Kelly. I'm a technical leader with EPRI. My background is in lithium-ion battery research and development, inspections, and failure analysis. For those of you who are unfamiliar with EPRI, we're a independent nonprofit energy research and development organization based in the US. We work on all things electricity. The team that I'm a part of focuses specifically on energy storage. That image on the bottom left, that is our energy storage roadmap that guides our research. And we believe that these 15 future states for energy storage can be achieved by 2025, fingers crossed. So today's discussion is about safety. Safety is one of the core pillars of our energy storage roadmap. We have a dedicated safety research project that is ongoing at EPRI that looks at specifically battery energy storage. The interest in this research was really sparked after the 2019 Arizona battery energy storage explosion. And it became very evident in the industry that there was not enough being done about safety. So this research project has happened in 2 phases. Phase 1 was really trying to understand the state of safety. And so the result of phase 1 was a fire safety roadmap that we developed. It identified 22 areas of research and technology development that we felt should be pursued to further improve safety. It was a nice bubble chart that shows, difficulty to achieve along a time and time to achieve axis. Phase 2 is looking at that fire safety roadmap and then trying to develop tools that in direct response to some of the gaps that we had found in the industry. So on the right side of this slide is just a pictorial example of some of the research that we have done. So we've done a battery burn testing to understand what the emissions are that come off of a battery when it's in thermal runaway. And this is helping to guide ongoing research right now, understanding fire plumes from a battery energy storage fire, as well as water runoff for firefighting. We also have a fire safety design trade study to understand the cost trade-offs of putting in safety retrofits. We have an explosion calculator. It takes into account NFPA 68 and 69 calculations. It's kind of a, just rough calculation based on the size of your system, what sort of venting that you expect, and it's looking at fire and explosion hazards. We are developing, and I think there may have been a first generation of this. I'm not sure exactly how far in development it is, but we're developing an augmented reality maintenance and safety tool. So operators can use this tool, walk around their site and use things like thermal imaging to identify if there's a hot module within the container and know not to enter the container. It gives you a general reading of what the state of charge is of your battery. Just important information that operators should be aware of before trying to enter any of these energy storage containers. At the bottom, I have first responder, VR training. That's something that we're hoping to develop. Part of our research is focused on helping to educate first responders because many firefighters have not dealt with a lithium-ion battery fire. Some of them have, unfortunately, had to put out either EV fires or BEIS fires, but the large majority of people don't know, when they're coming onto a site, what is there and what the best practice is and how to fight the fire. So we're hoping that an immersive kind of training tool is something that can help the industry with better safety practices. And this is just a flavor of some of the research that we're doing. storagewiki.epri.com is our go-to website for better understanding all of the research that we're doing. So I highly advise you to check it out if you are interested in the work that EPRI is doing.
Thanks, Taylor. And I particularly like to highlight the VR training. We got a little trial of that, which was really interesting to see how that would work in practice. And education is a massive part of it, right? That's fantastic. Julian, I'll move over to you at Fluence. Introduce yourself and your role in the sector.
Of course. Let me. I'll try to keep it short and snappy on this one, and then we can move on to the main discussion. So, Hi everyone, my name is Julian Jansen. I'm responsible for strategy, market development and policy at Fluence in the EMEA region. Who's Fluence? Fluence is the largest supplier of energy storage systems globally. We've deployed or are currently deploying 5.5 gigawatt of battery energy storage assets across, I think it's now more than 30 different markets. We've actually been deploying through our parent organization's storage systems since 2008, which means we've learned a lot of lessons and we understand how to put storage systems in the field, how to operate them in the long term, and how to make sure we maintain both performance and safety to the highest standard. We're now deploying our 6th generation battery energy storage system and are looking to actively drive standards in the industry forward because ultimately that's something that benefits all of us and it's really critical, I think, for the health of the industry and if we want to deploy more of this very critical technology to meet our energy transition goals. So that's really the role we are trying to take. We look to be the best-in-class leader on safety, and it's really inherent to us as an organization. It is a fundamental policy principle in this organization, is that safety is very much on top of the agenda across everywhere from design to installation to operation and services of the system.
Thanks, Julian. That's great. Thanks for having along. Matt from BEIS. Yeah, introduce yourself and, well, we know your role, but it'd be great to hear more from you.
Yeah, no, good afternoon, everybody. Yeah, so Matt Aldridge, Head of Electricity Storage Policy in BEIS. So I am responsible for all scales of storage. So that's the domestic batteries all the way up to, not for today's topic, but like that pumped hydro storage. So obviously that's got a huge array, but the health and safety issues are there extant throughout all of them. Now, my goal in BEIS, we came up with back in 2021 the Smart Systems and Flexibility Plan to try and make a smarter, more flexible energy system to get to net zero. And we're all about trying to find the barriers, removing the barriers to allow the market to come in and fill that gap to create that net zero energy system going forward. That's all well and good, but if we don't do that in a way that is safe, then we'll end up undermining the case for it. And there's quite a few policy interactions, which I'm keen to discuss later because it gets quite complex. Because although I sit in BEIS, whenever I talk about health and safety, I actually spend a lot of time talking to planners in DLUC. I talk to people in HSE, so the Health and Safety Executive, and people in the Home Office. So it becomes quite a complex network of government where everyone's trying to protect consumers as well as create the conditions for the market to bloom. But we're quite clear we're going to need lots more electricity storage, and that means lots more batteries and lithium-ion batteries across the country. We can't undermine the case for it by not doing this in a way where the regulation is safe going forward. So our approach is very much trying to work with you guys, work with industry to come up with the appropriate responses as we go forward. So thanks very much for having us here today, and I'm looking forward to the discussions going forward.
Great. Thanks, Matt. Comprehensive introduction, and a quick reminder to add your questions to the Q&A, and a reminder to kind of upvote those that you think are most interesting, and I will thread those through into the discussion wherever possible. So I think maybe just a quick introductory question again off the back of that really is where do we think the current state of best practice is in terms of fire safety? And we've got a bit of an international flavour here, but I'll probably try and hone it a little bit into the kind of UK market and then pull in international examples if that's okay. So I suppose maybe if I come to you, Julian, because you've got a pretty good view of some of the different moving parts, and obviously I think you guys are pretty active in Ireland as well. They're doing quite a lot there in terms of best practice. If I come to you first, Julian, and then we'll introduce the rest of the panel as well. So Julian.
Sure, can do. I think, ultimately we have to recognize that we're not dealing with a completely new novel technology, right? I think we have to recognize that batteries and their use are widespread, right? We've got 8.7 million EVs and plug-in hybrids across the world. We've got almost 5 billion mobile phones, probably got over 12 gigawatt hours of BESS operational across the world. So we're not dealing with a completely new technology. Of course, the specific technologies and use cases vary quite significantly across those, but we are dealing with a known technology, but we're just dealing with the scale up of a more novel application here. I think that's a really critical piece to always highlight when we talk about, in particular, battery safety. The point that I think for me is critical to look at right now is that I think in the UK, we have a real lack of clear standards and guidelines. Of course, there's some guidelines out there. That doesn't necessarily mean we're sitting there calling for UK specific standards or UK specific regulation, because there's actually a lot that we can learn from international standards, international regulation. If we look at, for example, now UL 9548 testing in the US as a really important example on how storage systems deal with thermal runaway and deal with explosions or fire events within the system, then that's something that we should say is applicable for the UK as it is for any other global market, really. I do think, however, there is a big gap and a need for the industry to move forward and really be forward-leaning and provide guidelines on what should be considered best practices and what should be considered best practices from a whole system approach, all the way from the very first point around testing and system design, all the way to operation and end of life, and also first responder training, which obviously Taylor really highlighted nicely earlier in her introduction already. So looking at that and being forward-leaning as an industry and come forward with what we consider best practice is, to me, the only way that we can continue to scale and to ensure that the technology we use in the field as we scale up is safe for operation and we don't risk alienating the communities where these assets are being built.
Thanks, Julian. That's a lot of good points there. I'll come to Kai next, if that's okay. And obviously, you've got very much a data focus to best practice, I suppose. But yeah, anything you want to add?
Well, first of all, I can only second what Julian just said. I think that it really hits, the nail on the head. And one thing that in all of us that are working in energy storage or in batteries, we're used to extreme growth rates because that's our daily business. But if you just take 2 steps back and you look at what's actually happening right now, like the speed at which we're ramping up production around the world, the speed at which we're bringing new technologies, be it silicon anodes or new, cathode flavors into the market, it's mind-boggling. And one problem or one challenge of scale really is, if you have a failure rate of 5 in a million, that's mostly okay for most applications. But if you start to build 100 billion of these types, 5 in a million is too many. So with increasing scale, the production quality must improve dramatically because otherwise the absolute failure numbers become unacceptable. And it's not just, battery production quality, but also, companies like Fluence and others, they grow extremely fast. It's difficult to have, at all times, highly qualified people staffed into these companies, and everyone's struggling with that. So really, just because of the fast growth of this industry, we are looking at systematic problems that affect safety. And one great example, I believe, where we can all learn a lot from is, this is not the first time that a new technology scales fast. If you just look at solar in the early 2000s, the exact same thing happened. Many of those companies that started solar in the 2000s, they're no longer around because something happened that, killed the company. You had fires, you had early failures, you had insane warranty claims, 30 years. 3 years later, that company was no longer around. And I think we can learn a lot from solar. And speaking about the data perspective, also one thing that we saw is that, today there's no commercially operated solar installation without an asset management software. The same goes for wind. If an asset is so expensive, you want to know if it's working and if it's safe. And I think that batteries are in this phase of professionalizing, and that we'll see much more of that in the next years.
Thanks, Kai. I'll come to you, Matt, next, if that's okay, because obviously you've got a very much focus on the UK GB market. And I think James in the chat mentioned there's an IET BEIS Code of Practice version 3 due to be coming out in 2023, and I know there's stuff ongoing in terms of the BEIS Health and Safety Governance Group. Yeah, what are your thoughts in terms of pulling together that best practice and standards that Julian mentioned and things like that?
So this is the thing, and I think I think I can't remember what your question was right at the beginning. But it was like how are we doing relative to the rest of the world, sort of thing, and regulations. And there's regulation there, and it's in lots of different places. And I think pulling it together is the key thing, and having a systematic way of learning from events around the world and inputting them into the way that we manage our regulation here is what's important. Yes, it's not new technology; it's a new application of technology, and it's being scaled up. But when it comes to regulation, that basically means it's new and it's coming at us in a way that we find it difficult to keep up with. The world of regulation isn't fast. Lots of people in industry like to run fast and break things, and I think I heard someone say that government's job is to run slow and put things back together. It's this we need to make sure we get it right, because if we get it wrong, we will do more harm to the industry in the long term. And I understand how that can be frustrating to lots of people in the industry. But if you look at world leaders on applying these technologies and smart systems across their grids around the world, and I'm thinking of Australia, and I'm thinking of the US, and I'm thinking of Europe, with there or thereabouts, we're all learning at the same pace, I think. So in answer to your original question, I think we're there, and I think we can do better. And I think a lot of the hard work's been done. It's just a case of pulling it all together into a way that's consumable for people to understand and learn from going forward.
Thanks, Matt. That's really helpful. And maybe I'll come to you, Taylor, now in terms of, how do you see the kind of best practice coming through? And obviously, you guys are doing a really good job in collating that into kind of a database, particularly around incidents and transparency, and those kind of issues come up all the time in the discussions as well. Anything you want to mention there, Taylor?
This is a very broad question. So best practice, I think, plays into the entire life cycle of the asset, right? So from procurement, design, implementation, O&M, response if there is a failure, and then decommissioning. And everybody who's involved in each of those different parts of the project are likely only involved in their part of the project. They might not be involved in every single step. And so this kind of goes back to education. And unfortunately, we learn by doing. There's only so much that we can learn from reading papers. We can say, theoretically, this should be safe. And then in practice, something fails and it's catastrophic. And the goal is to try and minimize those, or at least if there is a catastrophic failure, we can do it in a safe manner, in a controlled manner. This is where education comes in through the entire kind of life cycle of the system. So from design, understanding what sort of mitigating equipment can be introduced into the system to try and control a fire. When it comes to O&M, what sort of equipment do people need to be wearing? What do they need to be aware of when they're entering into a container? When it comes to a failure, who are the people that need to be on call? What are the first responders doing? Are they trained? Do they understand how to enter the premises? There are multiple facets of best practices, but understanding kind of the fundamentals of why a battery would fail and what the failure looks like can help to inform each of those steps along the process and help to develop best practices based on that.
Thanks, Taylor. Maybe a kind of follow-up to that, and there was a question in the Q&A regarding first responders and fire safety then. So and maybe Matt and Julian have points on this as well, as regarding, so how do you think first responders in the UK or in other jurisdictions are doing? Because I think we've had discussions in the working group regarding first responders, and I think the problem in the UK or GB is there's each fire service is quite distinct, and they have different practices and things like that. So, is there any kind of particular issues you're seeing with educating first responders and getting those kind of best practices within the first responder community, let's say? If I come to Matt first.
Yeah, I'll jump in to defend the fire brigade of the UK. There, it's like, yes, it's quite fragmented in the way it's organised, but the way they're approaching it and working with us and trying to learn, I think at the minute is better than that. Is much more joined up. So the Fire Chiefs Council are certainly leading on trying to understand the ways in which we can best plan and prevent incidents, and the way that when it comes to the planning of these sites, to ensure that they have the right access, the right water supply, and the right markings are all there. So they're very much leading on this, and they're actually looking into best practice across the fire services in the UK at the minute on how to approach these incidents. So they're definitely alert to it. And I think, through groups like the Health and Safety Governance Group, we hope to bring together industry alongside the fire services so they can talk to each other, because the fire services are obviously experts at putting out fires, but they're not experts in batteries, and you need to bring the two together. So hopefully we're facilitating that going forward. So yeah, I think they're approaching it well. I mean, how well that goes down, and as we've been talking about, the speed of the proliferation, and like you said at the beginning, we're talking a lot about grid sites here, but I think what worries a lot of fire, and I can't speak for the fire services, but from talking to them, what I think worries them a lot isn't necessarily the big industrial sites which are well labeled and things like this. It's actually scooters and electric cars and things in people's homes which are not as well regulated, not as well installed, and can have significant consequences in that way.
Great, thanks, Matt. That's very helpful, and good defence of the fire service. Apologies for that. Kai, I'll come to you, because I think you've done a fair bit of work in identifying causes, and particularly that angle at the end there around domestic, smaller scale risk associated there. Have you got any thoughts on that?
Yeah, so it's a big part of what we do as a company to analyze the operational data of batteries in all sorts of applications. A big part is BEIS, but also domestic storage, automotive, commercial vehicles, and so just to get everyone on the same page, every battery has a BMS, that continuously checks voltage, current, and temperature. And that data in most cases today already is accessible through a cloud, certainly for all BEIS projects, but also for domestic storage and for automotive. And by looking into that data and applying some physics-based models, some machine learning, you can actually dig deeper into what's going on inside of the battery. And in terms of safety, that is extremely helpful, because the most of the safety measures that we apply today are reactive or passive. Like, passive is, I'm just going to put more space between containers, so if I lose one, I don't lose another. And reactive mechanisms could be, my BMS shuts down when the temperature goes above 60 degrees Celsius or 50 degrees Celsius. But by the time it has reached that temperature, shutting off the system in most cases won't help you anymore. And so the question is really, can we go from passive and reactive to predictive? That would allow us to stop the operation before something happens. And coming to your question is, in order to do that, you need to know what to look for, right? So what we're basically doing, and I think what also some companies are doing in-house, is, can we identify internal processes of the battery that are highly correlated with safety relevant topics? And I'm just going to give you one example. I think that's for people that have worked with batteries a little bit is quick to explain lithium plating, right? Lithium plating is when you charge a battery and the lithium ions, they want to go into the anode and basically park there, but for whatever reason they can't, so they just plate onto the anode. So metallic lithium forms outside of the anode instead of going into it. And that metallic lithium is highly problematic. Metallic lithium, is very reactive. It forms razor sharp dendrites that can, damage the battery itself. And from looking into how the voltage and current of a battery change relative to the 10,000 other batteries in this site, you can actually see, 9,000 cells are going that way, and this one cell is going the other way. And we know that this is critical. And there's still a lot of untapped potential that we see that, can be applied to systems, even retrofitted really easily because the data is already there. But of course, data analytics cannot replace high production quality, cannot replace UL testing and all these other, fun things. It's just one additional layer.
Just to follow up and actually taking in a question from the Q&A is what do you see the differences between the stationary storage versus electric vehicles? Because I know you do both. Are there any particular kind of data requirements or differences between those two?
So actually the differences we see in battery data inside of an industry are as big as they are across industries. So if you're looking at large scale storage, we've seen everything from sub-second data to 1 minute data, although most systems now are in the 2 to 5 second range because they need to interact for trading in that frequency. So there are some quasi standards, but the quality of the data, it varies a lot from the major BEIS operators like Fluence and like others. We've seen fairly good data, but what we have seen also is that unless companies ask for this data proactively and maybe put it already into the tender or into any documentation pre-sales, they might have a hard time to get it later. So, my small advice is make sure you have access to the data from the very beginning. Whether you want to do it yourselves or work with someone else, it's valuable.
Great, thanks guys, that is nice and clear. I'll have another question for the Q&A then, if that's okay for the panel. It was regarding, is there a likelihood for regulations to be introduced regarding a locational criteria for energy storage? So I suppose that's that's the risk, right? So if we start getting the kind of exclusion zones for kind of developments and things like that, does anyone have a view on whether that is a kind of likelihood, a risk? I suppose I might come to Julian first, and then to Matt, and then Taylor.
Yeah, thanks, Ollie. I think, not too specifically on the exclusion zones, but one thing we have to ask ourselves, one, I don't necessarily think that's the right way to go down in terms of determining that from the very top down. The other thing we have to really ask ourselves is, where's a lot of location of value for these battery storage assets, which is often actually in demand centers or around demand centers, versus where maybe you don't want to build it, right? So there's a big question we have to ask ourselves: where's battery storage actually solving a lot of problems, even though you may say you don't want a site nearby. We're actually looking at California. A lot of these assets, very large gas peaking replacement assets, are being built in urban areas. And you know what? People are pretty happy because they have clean air. They don't have a fossil-based fired power plant around the corner polluting the air anymore. So actually for them, it's a much bigger improvement. Now, of course, there may be certain considerations to take, in particular, obviously, around nature reserves, any protected areas. Of course, that is a consideration, but we have to really think about it clearly. Is an exclusion zone actually counterproductive to what we want to achieve? Secondly, I think it's also really critical to take people on that journey. If these sites are, right, Taylor mentioned this earlier around the whole system approach, all the way from planning to end of life, mitigation alongside training of fire services in the local area. If the site is installed properly, designed properly, all mitigation and training measures are taken, then the risk to local communities is very, very limited. And in that case, I don't see the need to drive exclusion zones based on whatever measure they may be kind of followed. I think what's more critical is to make sure that the way it's installed is done properly, and that just doesn't just touch upon the electricals, but it touches up on the civils. Make sure that you have the right fencing around the site, etc., right? That comes into it. So making sure you have the right installation, making sure you have the right training mitigation plans with the local fire services, make sure they're trained from the very start of this project to know exactly what's happening, exactly how they should be responding, and then making also very clear what is happening with that site at the end of its life, and finding the right parameters around those areas. And actually, I think industry has to drive a lot of that forward based on the experience we've gathered, rather than coming down with top-down determined exclusion zones that may be somewhat arbitrary and counterproductive to what we're trying to achieve with these sites.
Thanks, Julian. Very clear. Matt, do you want to comment?
Yeah, I do, because I agree with everything Julian just said. But I do want to say there's a potential risk here, and that is with the public not understanding. So we've just, like, everyone in this room understands the risks, and we're all comfortable with the risks, and we all think the risks are minimal, and we all believe we can mitigate them, which is great. It doesn't take long for a tiny bit of hysteria to infect the way people perceive new technology, and that can really hold us back. So I guess my plea as someone who works in public policy is for industry to understand that the more open and the more progressive that we can be about this, and actually get ahead of it by putting in and almost voluntarily restricting ourselves and putting in mitigations, we will win over the public, who are the people that we're going to have to, like you say, like, locate these sites in urban areas where they're best required and they can best dispatch when, in the right time, in the right place. But it's about winning that over, and I think we don't exist in a bubble. Like, I have political masters that I interact with all the time. It almost doesn't matter how pro a minister is or anti a minister is, they also have parliament and they have their own constituents. So we don't exist in this wonderful technology bubble where we can just push it forward. We have to understand that we are providing services for consumers, and they need to be convinced that this is safe. So we all have a job of work to do there to make sure that the public understand exactly what these technologies are and what they're capable of.
But actually, just to add on that, Matt, sorry for interrupting, but I think just an important point. At the same time, I agree with you, and I agree industry has a responsibility, and we have to move that forward, and we have to take people on a journey. So 100% aligned with you on that. At the same time, we have investment signals, the way storage is currently earning money, that is encouraging a pure race to the bottom. And that's encouraging technology to come in from new suppliers with no track record, very little software capability, not really caring about the safety of these assets. And to a certain extent, if the asset makes money, maybe it does matter to some of those suppliers. So the question is, if we're driving incentives in one way that is driving actually low cost, because that's the only way to make the investment case pencil, that is a counterintuitive incentive if we're trying to at the same time get people to, from the start, think about safety, build projects properly, and engage with local communities on top of that.
No, I think it's a fair point, Julian, and I think there's a lot of new entrants to the market as well, and as Kai mentioned, so much growth. It's a challenge to avoid that race to the bottom, which you've seen in other industries for sure. Taylor, I'll bring you in here as well. So is there anything you'd like to kind of highlight in this area in terms of, from what Matt and Julian have been talking about there?
Yeah, I agree with both with what they've said. This is a complex kind of problem. So this is where in the US, the AHJ, or the authority having jurisdiction, plays a key role, because they will determine what codes or standards that the energy system needs to abide by when it is getting put into the ground. And so, and what the AHJ requires will vary across jurisdictions. So if you have a rural environment, they might not know a lot. There's a lot of open space. They might not really care. Put it in, let it burn. If it goes up, it's fine. But when you're dealing with urban communities and you have a lot of people around, there's extra care that they need to consider and should be taken to make sure that people's safety is thought of and incorporated into the system design. And with that, I will say community buy-in is so important. These days, everybody's a YouTube professor. Everybody knows everything about everything, right? I was talking to a firefighter, and he said, oh, you know, thermal runaway always leads to fire because it makes oxygen. It makes its own oxygen to burn, which is partially true, but not enough oxygen to, you know, create a fire and explode. And so there's little bits of truth in the things that people have heard and grabbed onto, but it's nuanced, and batteries are complex, and the failure mechanism is equally as complex. And so I think we have found that being proactive in community engagement and going to community leaders, especially in underserved communities, right, where they feel like they're being overlooked and overseen, being proactive, going into those communities, talking to leaders, explaining what the project is and how it's going to improve their quality of life, explain that this is not, you know, we are taking the safety measures that you are concerned about, and making sure that these systems are not going to pose a threat to you. And we have this all planned out. And that is very important in order to get rapid deployment, I think, in an agreeable fashion, and not just like forcing it, you know, onto the grid.
Great, thanks, Taylor.
Ollie,
sorry.
may I jump in?
Go for it.
One, because I think we now had, I think, a really great overview about, you know, the key stakeholders that we have here. It's the industry, it's the regulators, and it's the communities. But I think there's one stakeholder missing that actually sits kind of in the middle of all them, and that's insurance groups. You know, the traditional way to hedge against technology risk is to get an insurance. And most of, you know, especially in the BESS space, these are all, you know, project-based financing. So you have a bank loan that needs to be somehow hedged with an insurance, at least like a property damage insurance, most projects. And we've been working with insurance groups regarding property damage since the day we started this company. So for almost 3 years, we've been working with them, and we partner with a few. And these, you know, they face the same challenge, but they actually they're an outside party that needs to bet on the safety of a certain system and on the risk of that. And so they are having such a hard time. And although people, you know, you want to assume that there's these big mathematical models in the background and they have an exact answer for the risk. No. So you can see insurance rates skyrocketing after each individual fire. Although you have to say, well, statistically it happens once in a while. Why should the insurance rate be more higher the week after? Because they're humans. And I think there's a big gap between the speed at which the industry develops, and sometimes even communities, and, you know, all the stakeholders that have an interest in getting these things developed, and insurance groups that are basically like, maybe I'm not insuring any of those anymore. We've seen companies completely go out of it because they said, we don't know, we can't evaluate the risk. And I think this is one point, you know, where data comes in really handy to bring transparency into this process, and to give also insurance groups the opportunity to say, well, if you have all the red flags and still you do nothing about it, you can't point the finger at me for paying, you know, whatever happens then. And so I think this could be one enabler also to bring costs down, because the insurance costs for storage, Julian knows this much better than I do, have gone up substantially for many projects.
Very good point, Kai. I think, yeah, insurance has been definitely a big pointer in some of the working group discussions we've had, and the role insurance is playing in driving, I suppose, more focus on fire safety, particularly as you say, the prices have gone up so much. I'll widen the question a little bit then, in terms of, which we do have a question there around kind of visibility, clarity, and then maybe kind of summarize it by transparency. And the question from Andreas is regarding OEMs, but I think maybe I'll widen it to be what can we do as an industry to be more transparent around incidents, best practice, data, all those kind of things. And maybe if I start with Taylor, because I know you guys have got like an incident report as such on your wiki page, is that right, in terms of like an international incident report?
Yes. So transparency is key, and we try to make a lot of our safety research, at least the high level general learnings, public, and we're working to do that more and more. So we do have a battery energy storage failure incident database. You can find it on that storage wiki page, and we are tracking battery failure events globally. And I think that people that I've interacted with have found that to be hugely helpful, because when we're only working in one area, we tend to have our blinders on and we're only focused in that one area. And then we see how big the problem is. And like Korea has had a number of fires, but that's not something that we see in our news daily, right? And that helps to show that this is not an isolated problem. This is a global problem. And to Kai's point, scale up. And a lot of this manufacturing is happening in China, in Korea. And so getting that visibility is so important. And to one thing that I just want to say is I like the panel that we have here. It's a lot of very diverse backgrounds, but I think data is such an important piece, because data transcends any, local ideas or jurisdictions or regulations that we have. The data is the same across the board. The battery only charges to 4 point something volts and only discharges to however many volts. We can only use it so many ways. So if we have that data, regardless of where the battery has been, and we can understand how it's been used, we can more quantitatively, bet on this technology being very successful. We can understand how to safely and properly use it in other applications. So that visibility is important for the life cycle of the battery, as well as safety, just projects generally. And having more transparency, I think, is key, and it's something that we're really, really missing as an industry.
Thanks, Taylor. That's good. Maybe I'll come to you next, Julian, and then we might widen it as well in terms of, so transparency, obviously very important. And then if you've got a kind of a specific ask, as we're kind of running towards the end of time, is there any kind of specific ask that you think the industry should be working on, and if that from the electricity storage network point of view, or wider than that? Is there anything that we really need to be working more on? We've covered a lot of areas, but trying to kind of condense that down.
Yeah, actually, it's nice. I can combine both into a single answer, hopefully. So that should work well. I mean, look, I agree about transparency. I think it's really important. We have to be open as much as we can. We have to take people on that journey with us. And I think for that, if we make it around specifics and tangibles, we as the electricity storage network, but also in particular the working group, I think we have to really take a more forward-leaning posture. Develop some clear best practices, right? Those are not binding regulation, but best practices, which everyone should, as much as possible, adhere towards. But it's also something we can then share with local communities, with planners, with policymakers, with fire services, so they understand this is what the best practice looks like. And they can take that to whoever's building a site and say, this is what we want to hold, or the standard we want you to adhere to or hold up against. And that is, I think, a really critical point, because it touches up on transparency, but it also means we're forward-leaning as an industry. We take people on that journey, and we really communicate what we believe is best practice. And there's a great example. We're just doing that actually in Ireland with Energy Storage Ireland, doing exactly that exercise. It's ended up being a very, very long document, which was intended to be a short, concise, snappy document, but actually it's really critical. And we've engaged in Energy Storage Ireland. We've engaged with the fire services. So actually we had webinars with the fire chiefs across the Republic and Northern Ireland, because again, it's very critical to help them understand it and dispel myths. And again, the same can be done in the UK. There's great fire departments. Let's take them on that journey with us. Let's help educate them. Let's answer their questions open and transparently. We can have, Chatham House rules webinars where we have those discussions and we bring different experts to the table. So my call would really be to foster that transparency, to foster better standards, to allow us to scale. Let's develop some clear best practices, and let's communicate with the people for whom these matters the most.
Thank you, Julian. Very helpful. And yeah, Energy Storage Ireland doing great things. We'll try and emulate them as much as possible. Electricity storage network in the UK. Matt, I'll come to you next. Obviously, very much front and center for you guys, and you've got the kind of the existing health and safety governance group. Is there anything kind of asks that you have from us in the industry as well, or
I guess I sort of just repeat what I said earlier. So I agree with everything Julian said, and you know, we actually do have quite a good relationship, but we're going to have a busy year coming up. There is a private members bill to do with battery safety that's going through at the minute with Maria Miller. So I do ask that everyone is aware of that, like I said, that political dimension, which I know we can be dismissive of because we can think, oh, that's just fear mongering, or they just don't understand. We need to engage with these legislators and these lawmakers, because they have a huge effect, and they will direct policy. And if we're not careful, we'll end up being pushed down routes which not only do we not want, but are unnecessary and will harm the industry going forward in the future. So it's that we've all said it today, so you know, don't labour on about it too much, but it's that whole knowledge dispels fear, and being open and reaching out to communities. And it's, you know, it's a little bit of understanding where the risks are, but also really selling what this technology does, because you know, it just looks like batteries, and I don't think people really understand how important they are to get into net zero, really. So it's that whole bit.
Thanks, Matt. That's clear. Kai, wrapping up thoughts as we are rapidly running out of time. Any particular ask that you'd focus on? I'm guessing it will be around data.
Well, actually, I would say I have two topics. One is like me in my role as coming from a battery data company related, and one more broadly towards the industry. And, you know, all the things that we're discussing now are based on an insane growth of the entire industry. That is, if you look at the next 10 years at the very beginning of the curve, right? All of our goals for 2030, all of our electrification goals, directly or indirectly mean that the energy storage industry will grow about 30% year over year. That's scary, because it feels like everyone is already maxed out, you know, in terms of their attention span, in terms of what they can do. So we have a lot of stuff coming. And so I believe finding a good base that's scalable, right, to cope with all these new things. Now, sodium ions are coming. You know, the industry had shifted within 2 years from NMC-based cathodes to mostly LFP for stationary applications. 10 years ago, or even 7-8 years ago, LFP was dead. Like, people said, oh, you know, scaling effects of NMC, they're gonna, you know, take the whole market. No, they didn't. 2 years later, completely different technology. Deal with it. SOC calculation doesn't work. We're still building them. And so there's, you know, there's a lot of topics where I believe we need to find scalability to just be able to juggle all of these balls. So if everyone's, you know, doing their own thing, it won't work, just from a matter of scale. Specifically, when it comes to data, I would say we don't need standards, but best practices. So what Julian said, I totally echo that. It's enough if the willing can agree on a certain range of things we should do. When it comes to data, you know, I think we're in the process. We are bilaterally working with many of the storage companies, but maybe it would be time to do something more public, maybe later this year. But once we have interoperability, also for the project developers, if I have 5 different projects with 5 different data sets, it's not efficient, right? So in terms of scalability, we need a little bit more best practices or standards, but I think we're working on it. So this panel gives me hope.
Work in progress. I like that. Maybe that's a reasonably good message to end on. Plenty to be getting stuck in with. I'll just we are out of time, unfortunately. So I think we could carry on talking about this for a little while longer. but I'll just get the slides back up so I can just give you a quick outro in terms of what else we have coming up. So just a reminder, Electricity Storage Network is a membership organization. If you're not a member, please do join. It's very inexpensive and you get fantastic value. So I'm your kind of main contact. Please do drop me an email, and the details will be sent to you via email as well. And we have lots of working groups. So that's the main value you get from your membership, and obviously the one covering fire safety is on the bottom there, the sustainability, safety and supply chain. Our next meeting's in kind of 21st of March. But we've also got a whole other host of other stuff to kind of get to grips with and for you to get along to. And finally, just a kind of very quick thank you to all of our sponsors. Sorry, no, we'll go back to one more. I have one more session for you later on this afternoon on grid connections, the kind of key topic in the sector at the moment, apart from fire safety, which we've just covered. So hopefully some of you will be logging on to that. And a very final thank you to our sponsors, so Road Knight Taylor, which we'll be hearing from at 3 o'clock, Fluence, Julian and others, thank you very much for sponsoring, Schneider Electric, Ethical Power Connections, Ampex, and I just say thank you very much to our wonderful panel for taking the time out to have a discussion with us today, and see you all again soon at some point. Thanks all.